Welcome back, focused learners, to today's Explainer. We are unpacking something absolutely massive today. If you've been sitting there wondering how to bridge the gap between traditional coding and the booming multi-billion-dollar 2026 AI industry, well, you are in exactly the right place. We are going to build your ultimate step-by-step blueprint to becoming an AI engineer.
Okay, let's dive into this. Here's our roadmap for today. We're going on a bit of a hero's journey, starting with what this new role actually is, mastering the tools in the 2026 tech stack, walking through an intensive 8-month training ground, picking the absolute best courses, learning how to verify our work against AI detectors, and then finally, conquering the ultimate final boss, the AI interview.
First up, Section 1, the new AI engineer, a brand new discipline.
Now, there's a really crucial distinction here between two roles that constantly get confused. The title AI engineer literally barely existed 5 years ago. Traditional machine learning engineers, they're the ones training models completely from scratch, tweaking super complex architectures and wrestling with massive data sets. But the AI engineer, you're doing something fundamentally different. You aren't training models from scratch anymore. Instead, you are building production-ready apps right on top of foundation models like GPT, Claude, and Gemini. You're orchestrating LLMs and developing autonomous agents. It's this massive game-changing shift from pure research to practical, scalable application.
Which brings us to Section 2, the 2026 tech stack. Think of this as your literal arsenal.
So how do we actually build this technical foundation? Well, while the tooling landscape absolutely exploded back in 2023, Python is still your non-negotiable bedrock language. But what are you actually building with it? Mostly you're building Retrieval Augmented Generation, or RAG. It's basically a framework that pulls highly relevant context from a private database exactly when a user asks a query, and then it injects that context directly into the prompt. Why does this matter? Because it is the 2026 industry standard for making AI reliable on enterprise data without having to constantly fine-tune the model. It literally stops the AI from guessing and forces it to read your specific, verified documents.
And to make RAG possible, you need the heavy engines behind it, vector databases. You've got Pinecone, which totally dominates production scale because it's fully managed in the cloud and auto-scales like a dream. Then there's Weaviate, offering incredible flexibility with hybrid search, meaning it beautifully combines semantic vector meaning with exact keyword matching. Chroma is your absolute go-to for beginners and local prototyping because it just runs in memory, and pgvector is perfect if your team already uses Postgres and just wants to avoid spinning up a whole new infrastructure. And this brilliantly illustrates a key point. Whichever database you choose, your retrieval quality depends heavily on how you chunk your documents before they even go into the database. Poorly chunked data, that means poor retrieval, no matter how fancy your tool is.
Beyond the databases, you're going to need frameworks to orchestrate all this logic. LangChain is essentially the Ruby on Rails for LLM apps, super great for general workflows. LlamaIndex is the absolute master at ingesting and connecting your data to LLMs for those RAG pipelines. But take a look at LangGraph and CrewAI. These are built for AI agents. This is hands down the biggest shift in AI engineering right now. We're moving completely away from a model just answering a single prompt to autonomous agents that can actually plan, make decisions, use tools, and even retry multiple steps if they fail. It's wild.
So, how do you learn all of this without losing your mind? Let's move to Section 3, the 8-month roadmap, your training ground. Here is a super intensive 8-month progression plan, assuming you can put in about 4 hours of study a day. It is specifically designed to turn traditional coders or just highly dedicated beginners into absolute AI pros. In months 1 and 2, you are locking down Python, SQL, and data structures. And please, whatever you do, do not skip SQL. It's a huge pitfall for beginners because bad data makes bad AI, and SQL is exactly how you inspect your pipelines. Months 3 and 4, you move into math, stats, and traditional machine learning basics. Month 5 is where you get production ready with DevOps, MLOps, and Fast API. And finally, months 6 through 8 are where you specialize in deep learning, natural language processing, and building those complex Gen AI agents we just talked about.
Now, I know that timeline might look incredibly intimidating, but take a breath and remember this. You don't become a strong AI engineer by learning everything. You become one by learning the right things. The AI landscape is so noisy right now. You're going to see a new groundbreaking tool on social media literally every single day. You do not need to learn every shiny new framework. You just need to master the core tools that actually ship to production.
Let's look at exactly where you can learn those right things in Section 4, Top Courses to Take. The educational resources for AI engineering are completely different from traditional ML research.
DeepLearning.ai has these fantastic short courses that are bite-sized, modular, and extremely credible. They are perfect for filling in very specific knowledge gaps. If you're looking for a structured, intermediate look at the whole life cycle, the Generative AI with LLMs course, partnered with AWS, is stellar. And if you're like me and you learn best by just doing it, DataCamp's Associate AI Engineer track is great. It provides a really interactive in-browser editor, giving you that vital hands-on typing practice. Plus, it crucially covers LLM ops, which so many other courses just completely skip over.
Okay, so you've built your system, but how do you know the text it generates is actually verifiable? That brings us to Section 5, Navigating AI Detectors, the Ultimate Quality Check.
Before we can even talk about detection, we have to talk about the AI engineer's absolute worst enemy, hallucination. This happens when an AI model generates text that sounds incredibly confident, but is factually completely wrong or just entirely fabricated out of thin air. Mitigating this is going to be a massive part of your daily reality. You're going to spend a huge chunk of your time using RAG architectures and monitoring tools like Langsmith just to keep these models grounded in reality and stop them from making things up. Proving your system actually works is critical.
And because AI generates so much content these days, the market for AI detectors has absolutely exploded to verify all of it. Here is a neutral, quick look at the top players. GPT-0 really shines for educators, boasting around 99% accuracy on pure, unedited AI text. Originality AI is heavily relied upon by SEO and marketing teams because it's highly accurate on GPT-4. And Scribr is a really solid free tool, offering around 78% accuracy. But here is the most important thing you must understand as an engineer. These tools are probabilistic. They are not infallible magical lie detectors. They're just looking at statistical patterns to make a really highly educated guess.
And because they're just making statistical guesses based on those patterns, we run into a pretty wonderful irony. False positives happen all the time. In fact, if you're a human who happens to write with very clear, formal, and consistent sentence structures, you actually lower your text's burstiness score. Which means, writing too perfectly as a human can literally get you flagged as a robot by an AI detector. It's a little frustrating, sure, but it's definitely a funny quirk of how these probabilistic systems are designed.
All right, you've learned the stack, you've built the projects, you've evaluated the models. Now it is time for Section 6, Acing the AI Interview, the final boss.
So the crucial point is 60%. If you prepare for an AI engineering interview today, like it's still 2023, you are probably going to lose the job offer. Why? Because the interview landscape has shifted dramatically. At least 60% of the questions you're going to face are now heavily focused on generative AI, things like RAG, agents, and LLM evaluation, rather than your classical machine learning algorithms or standard whiteboard coding challenges.
Put yourself in the interview hot seat for just a second. The interviewer looks right at you and asks, "Design a RAG system for our customer support product. Where do you start?" This is the single most common, most critical system design question you will face in 2026. If you give a blank stare here, the interview is effectively over.
But don't panic. Here is your exact blueprint. You just break it down into 3 pipelines. First, the data pipeline. Explain exactly how you ingest, clean, chunk, and embed the documents. Second, the query pipeline. Talk about classifying the user intent and using hybrid search, combining semantic and keyword search. Third, generation. Passing those retrieved chunks to the LLM, validating the output, and citing your sources. To really blow them away, make sure you discuss the engineering trade-offs at each step. Talk about how different chunk sizes affect retrieval accuracy, or how you'd handle API rate limiting. That's what they want to hear.
Another massive tip for the interview is this: treat prompts like code. You need to prove to your interviewers that you view prompt engineering as a serious, rigorous production discipline, not just some fun party trick. Talk about storing prompts in version control, reviewing changes just like pull requests, and testing them against a strict evaluation suite before you ever deploy. Framing this as code as infrastructure completely separates the amateurs from the true professionals.
Finally, you're going to face the behavioral questions. Here is exactly how to handle them. When they ask about shipping AI, use the STAR method: situation, task, action, result, to really quantify your impact. When asked about hallucination, describe those multi-layered defenses we discussed earlier. Be totally ready to articulate the business trade-offs between building a RAG system versus fine-tuning a model. And critically, show them how you would explain AI limitations to non-technical stakeholders using concrete demos rather than confusing jargon. Showing mature judgment about reliability and clear communication, that is ultimately what secures the job offer.
Which brings us to our final thought.
As AI agents become increasingly autonomous and powerful, you have to ask yourself, are you simply going to be a consumer of these tools, or are you going to be the architect building the future right on top of them? The blueprint is in your hands. The tech stack is clear. The choice is yours. I highly encourage you to open up your code editor and start building your first RAG application today. Thanks so much for joining me on this explainer, and keep learning.